Hello everyone, welcome back to the Theory of Computation course, and in this video I'm going to explain about the basic terminology which is required in theory of computation to build mathematical models. So yeah, let's get started. So the first thing which we are going to learn now is called a set. So what is a set? Let's first understand this. So set is a collection of different objects. Distinct objects. Like, for example, if there is a set name called A, and in this set I have elements like 1, 2, 3, 4, and 5, this is a set. Why? Because it is a collection of different objects or elements. Like there is no same element present in this. Do you call this as a set? No, this is not a set because there are two ones in this set, which doesn't follow the definition. So a set is a collection of distinct objects. So I hope you got what is a set. Now let's understand what is relation. So what is this relation? So if I have two sets, like A is Ranga and B is Anish, let's say, and I have one more set which is the roll numbers of both. Now, if I want to relate these two sets, I can do it like this. So relation is nothing but it shows the connection between the two sets, how the elements of one set are connected to the other. Like now in this set A, Ranga is connected to, that is, he has roll number 101 and Anish has roll number 102. So in this way, both are connected, right? So this is what relation is. It shows the relation between two sets, like how set of elements of one set are connected to the other. So I hope you got what actually relation is. Now let's understand what is a function. A function is a special type of relation where every input has only one output. Like if there is a function called f of x and it is x square and it is x square, and you give input as f of 1, you get 1 square which is 1. And if I give you input as f of 2 and 2 square is 4. Like if I take input of any number, I'm going to just get one output. Like if I say f of 3, then the answer would be 9, but for the same input, there will not be another answer like 10 or 11 or anything like that. There is only one answer. So if a relation, like if it is a special type of relation where every input has only one output, but not more than one. So that is what a function is. And now let's try to understand what is an alphabet. So an alphabet in TOC is represented with sigma, and so this is called as an alphabet. So what is this alphabet? So alphabet is nothing but a set of symbols. So alphabet is nothing but a finite set of symbols. Like alphabet doesn't just mean A to Z. Not only this, anything like 1, 2, 3, at the rate, or anything. These are all alphabets. These all symbols are considered as alphabets. And the set which consists of these symbols is called as an alphabet. Suppose if I have a set A, B and C, this is an alphabet. If I have a set consisting of A to Z and 1, 2, 3, this is an alphabet. And if I have a set of symbols, this is an alphabet. So that is what alphabets are. That is what alphabet is. Like alphabet is set of symbols. That's what you need to remember. So I hope you got it. And the next thing which we are going to learn is strings. So then we have learned about alphabet. Now let's try to learn about strings. So what are these strings? So strings are combination of alphabets. Like any combination of the alphabet is called as a string. Suppose if I have an alphabet which says 0 and 1. So this is an alphabet and this alphabet only consists of 0 and 1. So whatever the strings which we are going to make must only be formed using these two digits which are present in an alphabet. So strings are a combination of alphabet. So whatever the alphabet which we are going to define, using only those symbols, we are going to form strings. So now how strings can be formed? There can be a string like this, 1, 0, 1, 0, 1, or 1, 0, 0, 0, 1, or 1, 1, 1, or 0, 0, 1, and there can be infinite possibilities, right? So this is, but do you think this is a string now? 1, 0, 2, this is a string? No. Why? Because 2 is not defined in the alphabet. It's not part of the alphabet. So strings are a sequence of symbols which are taken from the alphabet. So you need to form the strings only from the alphabet, and you should not necessarily create or add other symbols. So the combination of alphabets or sequence of symbols present in the alphabet is called strings. So I hope you got what are strings. Now let us try to understand what is a language. Now you got to know about alphabet, you got to know about strings, and this one is called language. So language is nothing but collection of strings. So this is collection of strings. Like before I said there are strings, I used the alphabet 0, 1 and I made strings like 1, 1, 0, 1, 0, 0, 1. So all the collection of this is called as a language. But generally in TOC, what happens is a language is defined based on some rules. Like in TOC, generally, suppose if there is an alphabet, say 0, 1, and now if you create a language, the language must follow a set of rules. Like, as I said, language is a collection of strings. So if at all I want to create a mathematical model that accepts only strings which have which ends with 1, let's say. So now whatever the combination of strings which we are going to accept, that is a language, right? Whatever the collection of strings which we are going to accept should only have 1 at the ending. So it is a rule. So this language is following a rule called my strings, whatever the strings inside me, should consist of 1 at the ending. Like suppose if I say there is an input string called 100, do you think our mathematical model should accept this? or reject this. So according to our rule, this should be not accepted. Why? Because it is not ending with 1. Now, if at all I say 101, do you think it should be accepted? Of course, it should be, because it is ending with a 1. So that is what a language is. So language is a collection of strings which follows some rules. Okay, so that is what a language is. And the next thing which we are going to learn is what are states and what are state diagrams. After learning them, then we will learn about the models, mathematical models, and the first model which we are going to learn is DFA. So let us understand what is a state. So basically a state is represented with a circle and a notation inside it. Like we represent a state with Q0, this is state 0, and this is state 1, and this is state 2, state 3, like this. So we actually show states in this way, like a circle. And in every mathematical model, we will develop a state diagram, like which consists of these paths, like these states, like Q0 state, Q1 state, Q2 state, Q3 state. And now each state takes an input and it will transit to the other state. So each state will take an input and it will move to the other state. And this will become more clear when I will explain about DFA model. But the one thing you need to understand is a state will accept some input and it will go under transition to the other state, and that state will also take some input, and based on the input it may change its state or stay in the same state or transit to other state. So this is what is going to happen generally in the mathematical models. Suppose if I say if Q0 receives 1 as an input, you need to move to Q1. And if Q1 receives 0 as an input, you need to move to Q2. And if Q2 receives 1 as an input, you need to stay there itself. If Q2 receives 0 as an input, then you need to move to Q3. So this is how the transition happens. So basically there will be states, and with these states we are going to develop some diagrams, that is the mathematical representation of the diagrams. And with that diagrams, that explains how the system or computation is working. So this is how we are going to represent the mathematical models using states, input symbols, and how input paths are moving. Like if a state receives an input, to which state it moves, like the input paths and everything which we are going to learn in the next, I'll explain it in the next video. So this is the basic thing you need to keep in mind in TOC. So yeah, that's enough for this video, and in the next video I'll start explaining about the DFA model. Yeah, that's it. Thanks for watching.